Well, good afternoon, everyone. In the today's topic of electronic subject, that is operational amplifiers, we'll be discussing the overview. It's what is meant by operational amplifier and the characteristics of the ideal and real operational amplifier, common operational amplifier circuits, and where it has been utilized. That is related to the application point of view. Basically, would like to know what is meant by an operational amplifier, and in short, that will be calling it as an op amp. It's an electrical component which is used to amplify a signal using an external power source. They are generally composed of different types. It is transistors, resistors, and capacitors. And a combination, an operational amplifier will be connected with respect to the circuit design, and the connectivities will be given to the input ports, and the corresponding output has been verified from the output ports of this microprocessor. Here this is a microprocessor, there is 8-pin microprocessor clearly indicating here, and these are the ports, and we will be these are the input ports. We'll be verifying or identifying the input ports and output ports with respect to this particular microprocessor is based upon this notch, and as per the this notch will be existing only one side, and the other side will not be existing, and this notch left side will be consisting of input ports, and simultaneously another four more ports will be existing in the right side of this particular notch, and those will be output port. The major power supply will be given to this one, and one will be grounding, given to the ground connection, and two input ports will be existing primarily. Simultaneously voltage input, voltage output, and drain current, status current, and corresponding outputs based upon the given inputs will be obtained in the output ports. So to these ports, the components will be connected with respect to an wire system by the operational process of this soldering basis, and the program will be dumped to the microprocessor, and based upon the given components connections, certain progression as per the programming will be processed by this microprocessor. Corresponding outputs will be getting generated. So hence we will be calling this an op amp, which will be generally consists of the electrical components such as transistors, resistors, and capacitors. One can history. Yeah, here it's a clear-cut description related to the uh, components which has been arranged in the motherboard, and this particular motherboard connections in the form of circuit system has been identified here, but in slight variable as per the generation basis. The first patent vacuum tubes that has been developed in the year 1946. Later on in the 1953, first commercial operational amplifiers came into the existence. Later on, the discrete ICs of operational amplifiers. So this IC represents the integration circuit operational amplifier, and later on in the next generation, the successfully monolithic, or that is occupying and very much less space within a one board, came into the existence in the year 1965. Moving on to the 1967, that is the latest modern period, that integrated circuit, which is developed in the 1967, and even that is the circuit executing in a present days VLSA circuits also widely utilizing in the present days domestic basis, industrial basis, in automobile fields, etc. As per our requirements, the programming will be fed in the microprocessor, and based upon that, the connections will be progressed and corresponding output will be getting generated. Here, as per the ports in the input region to the output region, I have discussed that ground connection will be existing, and in the forward basis of operation, the reverse basis of operation. In the previous sections, as per the bipolar junction transistor, JFETs, junction field effect transistors, and MOSFETs, that is metal oxide field effect transistors, metal oxide semiconductor field effect transistors, MOSFETs. We have been seen that they will be operating in a forward characteristics when the input has been given to that components, and corresponding output characteristics, VI characteristics, that is voltage and current characteristics will be verified. Simultaneously, when it is has been reverse biased, corresponding negative voltage and the current characteristics are also verified. So there we have a clear cut signation that upon sandwiching of the diode and transistor will be taking place. Upon sandwiching of two different two transistors, we are obtaining bipolar junction transistor. This combination of two transistors, and what are the common N regions and common P regions based upon the polarities we have been discussed in the previous class. And advanced to that, diodes, the combination here, the similar components combination generates the another components. Just we have been discussed that combination of two diodes leads to the transistor, combination of two transistors lead to the bipolar junction transistor, MOSFETs, JFETs, and combination of those transistors will be with an additional merging as per the requirement leads to 10 JFET, MOSFET, etc. depending upon the type of material we have been utilized. And presently, moving on to the today's session, we are discussing this operational amplifier, which is a combination of multi strategies. Multi strategies. So, there in the previous sessions, we have been called as a positive way of operating, we have called as a forward bias, negative characterizations, as we have got, we are calling it as an reverse bias affirmation. But in the case of this operational amplifier, this positive is called non-inverting characterizations as with respect to pin 3 connections we have been seeing. And inverting characteristics, that is indicated with respect to a negative symbolic representation. And when it is an offset null, there is a null operation, there is no any operations at that particular phase. And power supply, that is fourth one. And offset in the sense this is generally called as a ground connection. Ground connection. And next one, offset null simultaneously in the right hand side. And output achievement 1, and voltage output, power output. Power input is 1 and power voltage output is 1 port, and there's an ENC not connected. There is, if there is any additional parameters other than the ground connections, those will be which need to be in an ideal mode, without passing any of the power supply into that particular component, that will be connected to this ENC port, that is not connected port 8. So the major statistics as per our criteria is inverting strategy and non-inverting strategy, and the output that is being obtained based on the given input to the operational amplifier. So we will be considering an operational and their math, how the calculations are being taken place here refers to an operational amplifier indicates with respect to voltage, that is non-inverting input positive, inverting negative output V output, and the passage of current, that is power supply, towards the positive Vs plus and towards the negative power supply, that is Vs minus. Hence, upon calculating of this voltage output, a constant K, there is a gain factor or amplification factor. The gain that is has been obtained upon the calculation part that is being done between the two different ports that is connected to an operational amplifier for an amplification process. And hence K is the amplification factor. Hence K of and multiplication or a product of K with respect to voltage, there is positive power supply minus negative power supply. There is inverting strategy, non-inverting strategy. Hence, output voltage refers to the product of amplification factor to the non-inverting input minus the inverting input. Hence, the output is a product of this K into V plus minus V minus. And this output can only be an high as the difference between power supply, that is positive to the negative and with respect to the ground connections. And these output voltage will be varying based upon these three different parameters: passage of voltage with respect to the positive and with respect to the negative, and we are almost having the ground connections, there is zero connection or NC connection, there is no connection, as we have discussed in the previous session. There is no connection, and this offset, that is offset null, in the sense there is no any connections will be given to the ground connections. So in the case of this nominal mode of operation, this operational amplifier, what are the different conditions that are being taken place, and what are the saturation points during positive voltage and towards the negative voltage in the practical scenario or practically operational amplifier refers to generate the voltage output in the case of positive frequency region and negative frequency region. Will be verifying with respect to the diagrammatical basis. Saturation leads to a phases, that is increasing and decreasing the input voltage to generate the corresponding output voltage to the equal power supply voltage. Considering the major level, that is when considering the gain of the operational amplifier, it is shown here the gain of an operational amplifier with respect to the linear increment of the voltage input, the corresponding output will be getting generated. This is linear. So up to where? Up to a maximum point, that is saturation region, up to a maximum point of the input, and even further input has been supplied, there will not be any gain with respect to the positive portion. It will be a constant or stabilizing at a particular point. So what is that? Potentially just a few millivolts of change in the difference of between voltage positive and the negative could cause the operational amplifiers to leads to saturation. So the difference that is being taking place between this positive and the negative leads positive and negative leads to a saturation region. Hence, the saturation level of, of this operational amplifier leads to the 80% of the supply voltage. And moving on to the characteristics of ideal and real operational amplifier. So here, what are the different characteristics or nothing but parameters existing for an ideal operational amplifier? There will be infinite voltage gain, that is output. In the case of increasing towards the positive power supply and negative power supply based upon the given input, infinite input impedance, zero output impedance, infinite bandwidth, zero input offset voltage. These are the some of the characteristics we'll be verifying in detail. For an ideal case of operational amplifier, what are the gain factors or input output variations will be existing as per the standard will be seeing now. Coming to the point of differential voltage gain, for an ideal operational amplifier it is infinity, and for a real operational amplifier it is 10 to the power of 5 to 10 to the power of 9. And gain bandwidth product in the heads, that is infinity, there is no any limit value, that leads to infinity in the case of ideal, and real it is 1 to 20 megahertz. Next one, related to the input resistance, it is infinity, and related to the in the case of this real operational amplifier, 10 to the power of 6 to 10 to the power of 12 ohms. And output resistance leads to, in the case of ideal operational amplifier, 0, and in the case of this real operational amplifier, 100 to 1000 ohms. So the circuit variations related to the ideal mode of operational amplifier, because there is no any input pulse given to the system, and the corresponding output also will not be generating into it. Just as per the geographical conditions, this component will be coming into the working force. As far as this real basis system, the resistances will be given as an input, and based upon the incrementing in the resistance levels, simultaneously the output or charge carriers in the form of an voltage, that is either Vs plus will be fluctuating, or Vs minus, that is a negative voltage can be, or negative power supply can be increasing or decreasing based upon the input given to the input resistance, that is V input voltage input at the input resistance at external from the external characterizations. And this leads to the variations that has been obtained at an output, that will be measures with respect to the resistance that has been connected at the output terminal, right? And the difference can be identified, that is gain voltage, which is the gain voltage. Based upon the given input voltage, what is the incrementing or decrementing that has been considered, and will be connected with respect to the load resistor or output resistor at the end. And the difference, if for example, if 2 volts of power supply has been given in the input resistor, as per the characterization, it has been increased furtherly because of its variations in the case of the parameters such as voltage gain, bandwidth, and output resistance need to be obtained. and it has been developed at the output resistance, for example, it is equal to 5 volts, then it is a multiplication factor that already we have been learned, that K into Vs plus minus Vs minus power supply minus power supply negative. So that will be obtained in the calculation part of this R, that is resistance output. So what are the common operational amplifiers circuits are existing in our strategy or in our existence basis? We'll be looking at. Going on to the basics of a common utilization of these operational amplifier circuits. The major difference, as we have just visualized, now we need to calculate the output as a product of this voltage gain or K into V plus, that is positive, or positive power supply minus negative power supply. Generally, there will be an standard value depending upon the constant limitations of each and every component, electrical component, not only in the electrical, even in our mechanical components also. For example, if you have been considered the micrometer, the range of measuring it is 0 to 25 maximum, and vernier calipers also simultaneously the same. Likewise, the standard calculations or existing constant values to the operational amplifiers, that too the common mode of amplifier which is utilizing in the basic circuits, electrical circuits, for amplification of the input signal, indeed to double the input towards the output, or else there's a multiplication factor of n number of times that has been given based upon the input, and corresponding output will be getting generated. But typically K is very much large, and it will be of around 10,000 or more for integrated circuit of op-amps. Here IC refers to the integrated circuit. So integrated circuit refers to a combination of transistors, resistors, diodes, etc., as we have been seen in the previous slides. So this is the equation that basis for all the types of amplifiers that we will be discussing. So this is the basic parameter need to be identified, and 10,000, at around 10,000, and K is very much typically high in the case of integrated circuit. It is a combination of different components of electrical circuits. Moving on to the differences between two with open loop and closed loop characteristics. The closed loop amplifier will be having the feedback. As we all know that in the case of control systems also, in the first year we have been learned that the open loop is nothing but the output that will be generating based upon the given input, and it may not be equal to the standard values. The obtained values need to be considered as standard values at each and every phase. But as per the closed loop control system, it's not meant like that. As per the input voltage resistance, the corresponding output will be obtained, and corresponding output must be satisfied with respect to the demand conditions. So demand conditions here refers to the whatever the output should be or must be obtained, that will be amplified. So here amplification refers to the difference calculations based upon the given input. For example, if the output need to be obtained of a 5 volts and input given of 2 volts, the amplification need to be done internally. That is an operational process that is taking place in the case of this operational amplifier, and leads to the generation of a 5 volts of power supply at an external terminal output. So if the 4.5 or 4 volts has been generated, then in the field exists with respect to the input resistance, and the amplification should be higher indeed to satisfy the 5 volts of condition at the demand condition, that is voltage output, until that particular output generates the 5 volts of electrical power supply. That's the main motto of this operational amplifier, which will be utilizing in the general circuits. Yes, a non-inverting operational amplifier. So this is indicated with respect to the positive signature. So here, don't get confused. Non-inverting refers to the positive indication. Inverting refers to the negative implication. So generally, inverting in the sense positive, non-inverting in the sense negative. So non refers to negative, like that. Generally, you will be getting confused. So here, non-inverting refers to the positive implication. So it amplifies the input voltage by constant, and it's a closed loop operational amplifier. Voltage input is converted to the connected to the non-inverting, that is positive input. Voltage output is connected to the inverting input to a feedback resistor. Inverting input is also connected to the ground. So here, ground in the sense it always specifies the negative signalation. So non-inverting input only determined when voltage out. So we'll be verifying also. We already know that ideal amplifier and real case of amplifiers will be calculated with respect to a product of this k into the positive positive voltage converter and towards the negative minus negative signal condition. Hence, in the case of this non-inverting amplifier, the resistor 1 will be uh, seeing in the case of this, yeah, in the case of one of the diagram here, it is an integrating or inverting characteristics. As we have discussed in the previous slide, we have a diagram representation. Yes, this is a diagrammatic representation. Voltage input has been given towards the positive and corresponding output reverse to the negative, and that resistor will monitor with respect to the input resistor 1, which has been given a connection to the ground. So here the condition has been satisfied. So there is a characteristics need to be verified. Hence input resistor R1 leads to of R1 plus R2, and hence voltage output gain is refers to the negative voltage simulations leads to output voltage of R1 by R1 plus R2. Hence, the voltage at the output refers to voltage input given minus the voltage output of R1 by R1 plus R2 of into the K. So, we all know that the K is a very much large value that leads to a maximum of 10,000. The standard value in the case of this normal mode of operation, as we have been discussed. So, with that, we'll be coming to a conclusion that this voltage input output is equal to input by 1 by k plus r1 by r1 plus r2. And substituting or consideration of this k value as very much high will be obtaining of this voltage output is equal to taking a common factor of r1 leads to the 1 plus r2 by r1. Hence r1 by r1 plus r2, hence r1 has been taken into the common factor, and hence b voltage input of 1 plus r2 by r1. So this is the factor that need to be identified. This is a basic formulation you'll be getting even in the 1 mark questions. That what is the voltage gain at an output in the case of non-inverting operational amplifier. So here the answer is voltage output is equal to voltage input of 1 plus R2 by R1. Right? So in the case of this inverting operational amplifier, that the negative polarities are being connected to the circuits. So here we'll be verifying with respect to the diagram. Hence, in the case of this inverting, this voltage input will be giving to the negative terminal, and hence these polarities will be interchanged. Voltage input will be connecting to a negative, and ground will be connecting to the positive. So those will be the, and remaining almost all the circuit is similar. and depending upon that, the resistance values will be getting differed, and voltage output is also getting differed. So in what way it is getting differed, and what are the parameters that are being changed, we'll be looking clear, right? So this is the inverting operational amplifier. So it amplifies and inverts the input voltage, and hence it's an no doubt it's a closed loop operational amplifier. And non-inverting input is determined by both the voltage input and output, and hence the polarity change. There is some polarity of the output voltage is opposite to that of the input voltage. Just there is change in, and voltage input is connected to the inverting input. So hence input voltage is connected to the inverting input. That is a negative sign parameter. And voltage output is connected to the inverting input through a feedback resistor. Same feedback resistor, because feedback will be existing because of considering this as a closed loop operational amplifier, and hence in the closed loop operational amplifier the output will be getting monitored based upon the given input, and the comparison element will be getting taken place, and the necessary output needs to be generated as per the given input. Hence non-inverting input is grounded. Hence, already we have been seen that non-inverting. So non-inverting in the sense ground. Voltage input will be of a negative signation. Non-inverting is positive, and hence positive will be coming to here, interchanging of these values, and this is being grounded. All right. And in this case, we'll be getting a common terminal, or the amplifier. It is voltage output of K of V plus minus V minus voltage carrying, and refers to an voltage of, in the case of inverting operational amplifier, voltage output is equal to minus voltage in of Rf by Rn. There is a feedback resistance by input resistance. So there will be another one more question in the case of this 1 mark bits that are being faced by an objective more questions to you in the case of mid examinations point of view. There is, what is the voltage gain in the case of voltage output gain in the case of this inverting operational amplifier? Hence your answer it is this. Voltage output is equal to minus voltage gain of product of minus voltage input to the reference resistor by the input resistance. There is a feedback resistance. Right? Feedback resistance here refers to the output resistance to the input resistance. Right? So integrating operational amplifiers. So what is meant by integrating? Integrating here refers to the combination of two different operational amplifiers. So integrating refers to a combination of two different operational amplifiers. So here it integrates the inverted input signal over time. It is a closed loop operational amplifier because the output need to be monitored, output resistance should be given to an input resistance, the difference need to be identified based upon the output obtained in the processing as per the given input. And voltage output is connected to the inverting input to a capacitor, a resistor, as it clearly specifies here, connected to a capacitor. Voltage output has been, here it is an output connected to a capacitor, to an input, to an inverting input. Next, resistor and a capacitor form an RC circuit. Here, resistance and capacitor circuit, RC circuit, it will be framing. Upon the connection with respect to the output to the inverting terminal, that is negative, that's an inverting, positive, that is non-inverting, right? So hence this loop has been framed out, or circuit has been framed out RC, and hence this resistor R and capacitor C. So hence RC circuit has been framed up. Magnitude of the output is determined by length of the time voltage is present at input. As per the magnitude of output determines based upon the length and time of the voltage in the input present at the input, that is depending upon the input resistance that is being fed to an inverting strategy of an operational amplifier. The longer the input voltage is present, the greater the output. So if the input voltage it is present at very long range, then output will be very much high. And when the circuit is first connected, the capacitor acts as in short and gain is less than unity value and output will be as 0. So initially this capacitor, if it has been connected with respect to the input resistance, hence it is leading to a formation of RC circuit, and hence the input resistance when it has been passed to the capacitor, then automatically operational amplifier doesn't amplifies and simultaneously it corresponds to a value of zero output generation. So that is the point it has been refers to here. And even voltage gain will be very much less than the unit. That is nothing but 0.5, 0.2, 0.1 in such a way will be obtained. As the time progresses and the capacitor charges, if the operational process, amplification process is being done as per the time basis, the capacitor will be charges and effective resistance will be getting increased at the input level. And next, depending upon the incrementing of the resistance, the output strategy also will be increasing simultaneously. And when the capacitor is fully charged, it acts as an open circuit because the infinite resistance will be existing, and this at that particular time the output will be moving on to the saturation. Previously we have been seeing what has been the saturation. So upon increasing of the input voltage, even the input has been supplying continuously to the circuit, there will not be any changes in the case of this output, and it is stabilizing to a particular value. There's no any changes or alternations that has been done in the output factors. As we have been seen in the previous slides, we'll be just verifying once the characteristics as per the characteristics. Yes, in this particular item, as the input voltage even it has been given, and it will be moving on to a particular value, and next even the input has been given furtherly, there will not be corresponding output achievement because the capacitor is pretty much fully charged and it is having an infinity value and stabilized in saturation level that leads to in saturation level. Simultaneously, in the case of this negative voltage carriers also will be acting in the same role. Alright, the same role because we are having this differential in the case of voltage gain and time. Alright, next. The rate of voltage output increases depends upon the RC time constant. That is the loop that has been framed up with respect to the resistance and the capacitor. And hence the output, that is minus voltage input by resistance and the capacitor resistance with respect to input resistance. So capacitor resistance, here we have discussed regarding this. So capacitor resistance in the sense upon charging the resistor will be acting in an inverting, hence it is leads to a saturation point, and the output voltage is also written in the form of with respect to the time basis when it has been considered, that is minus 1 by RC resistance of capacitor RC from integration of 0 to the time value t voltage input of tau into dt. Alright, t into dt. So these are the characteristics that have been characterized in the case of integrating operational amplifier. Creates a sawtooth signal and and this is then called as a sawtooth signal, and this is a sawtooth signal, and this is a square wave generated at a voltage input. So based upon the given input voltage, there is square wave that is from 0 to the positive 1 and negative 1, and the corresponding output upon integrating circuit will be generating this way the characteristics. That is sawtooth characteristics. All right. So next one, the differential amplifier. So we'll be moving on to the differential amplifier in the case of in the next class. All right. Now, as far as if now we have been discussed the following points that will be having a overlook once again. That is the what is meant by an amplifier is an device used to amplify a signal when the external power source is given, and what consists of operational amplifier consists of it consists of transistors, resistors and capacitors, and a brief historical representation towards it. And the present day is 1967 of this operational amplifier and its connectors that we are utilizing in the present conditions, and what are the mathematical calculations based upon the non-inverting and inverting strategy application of this voltage, and what are the amplification factors that need to be obtained based upon the input given and output is being obtained. What are the saturation points even when the input has been increased furtherly? What is meant by saturation and how it will be gained, and then output, and even the when the given input is being increasing linearly, why that limits to a particular value, as we have been discussed in the integrated circuit that a capacitor charges and holds within a fully charged condition to an infinity conditions, and that leads to an saturation region, that is corresponding output leads to an non-generation. Again, characteristics of this in the case of ideal mode and this real mode conditions. And in the case of ideal mode, voltage gain infinity, bandwidth gain infinity, input resistance infinity, output resistance 0. In the case of real basis 10 to the power of 5 to 10 to the power of 9, 1 to 20 megahertz in the case of bandwidth gain, 10 to the power of 6 to 12 ohms scale in the case of input resistance, simultaneously 100 to 1000 ohms in the case of output resistance. Alright, so the connections and common factors depending upon the open loop and closed loop we have been discussed, and the integrating circuit based upon the given square wave input output will be obtained as sawtooth condition. Differential amplifier will be looking in the next class. Thank you.